Okay, now for this kind of problem, we're calculating the average, the weighted atomic mass. Now, one of the things you guys need to understand is that, if you're averaging two grades, that's really, really simple, or things that are equal. But the problem here is this. We actually have two different weights for boron. One is 10.1 and one is 11.1. All right, in other words, there are two different atomic weights. One form of boron probably has 5 neutrons, and one form of boron has 6 neutrons. All right, so now here's the problem, is that what we want to do here is we want to figure out what the weighted atomic average is. In other words, if you take a look at this, you only have 20% of the boron is the lighter guy. A full 80% of the boron is the heavier version. All right, so that means that the eventual, whatever the average weight is going to be, it's going to be a lot closer to 11 than it is to 10 because there's a lot more that weighs 11. All right, so let's just actually take a look at this and figure out how we can do this. All right, well, the first thing I'm going to suggest is that you guys actually draw yourself a little chart like we did. All right, so in other words, do this like you're doing it on a spreadsheet. One of the things I keep on telling you guys is you're not really bad at math, you're bad at bookkeeping. All right, you're not keeping your stuff neat. So one of the things I'm going to encourage you guys is to just draw this out exactly this way. All right, now the first thing is, all right, we have 10.1 AMUs, atomic mass units, and we have 11.01 atomic mass units for the boron 11. All right, so now we're going to multiply them by the percent, but there's a little trick that you guys seem to keep on forgetting. All right, a percent, 19% is not 19.9. 19% is 19.9 per 100, so divided by 100. 80% is not 80, it's 80 divided by 100. So what does that mean? Well, if you take 80 by 100 and divide it by 100, what you're really doing is you're moving the decimal over two places. And the same thing with this guy here. It's not 80.1. If you divide 80.1 by 100, you move the decimal over two places. So my suggestion is that you just write it that way. You just move the decimal over two places. Where you guys get confused if it's a small number, if you move the decimal over, say if it's 0.1 and you move the decimal over two places, it becomes 0.001. Try not to make that mistake. All right, so let's pop up the calculator. I'm going to do this real quick. And I'm not going to do it for both of these. I'm just going to do it for this first one. You're going to take 10.01 and I'm going to multiply it by 0.199, and that equals 1.99. Now, since there's only 3 significant figures here, I'm just going to round it off to that number. All right. Now, 0.8, 0.0, and I'm not going to bother you by showing you how to plug in the calculator. You should know how to do that. 0.801 times 11.01 equals 8.82. If you add those two together, you get an average. The total of those two is 10.81, which, as you notice, 10.81 is about 80% of the way between 10 and 11. It's closer to 11 than it is to 10. So the answer here is going to be, the answer in atomic mass units, the weighted atomic mass is 10.81. I strongly, strongly encourage you to set it up this way. All right? Where you'll make a mistake is moving the decimal over. So try to remember not to make that mistake. Okay? So that's it for this kind of problem.